All right, welcome back. So this is another ALEKS topic that's called using the conditions of spontaneity to deduce the signs of delta H and delta S. And again, this is a fairly straightforward topic once you understand sort of what it's asking. And what we really do need to sort of base our answers on is this equation, Gibbs free energy equation, delta G equals delta H minus T delta S. We're just sort of going to be utilizing this equation to tell us some information in order to figure out what's going on. And I've also made this sort of handy chart that we will use. I've used this on a different video, so you might recognize it from that. I've added in some information to this. So I added in the delta G for an exothermic reaction with a decrease in entropy. It says sometimes, and that means when delta G is negative at low temperatures, and then here, if it's positive, delta G is negative at high temperatures. So we'll talk more about that as we get into our example. So again, I'm going to do two different versions of this problem to get us exposed to a variety of different questions. But let's go and get started. So this reaction is spontaneous except above 43 degrees. So this reaction is spontaneous. It's going to be one of these first three. So the bottom one is always non-spontaneous. So if the reaction is spontaneous at some point, then it can't be the bottom one. And the fact that it says except above is also going to rule out the top one. That means that, if it was negative positive, then it's always going to be spontaneous. So it's got to be one of these. And then we just need to decide which one it is based off of, the fact that except above 43 degrees. So basically what this is, another way, that we could say this is that the reaction is spontaneous at low temperature. As we heat this reaction up, it's going to become less and less spontaneous, which is somewhat weird. But if you think about the effect of delta S, if it is a negative change in entropy, the higher the temperature goes, then the more unfavorable that's going to be, right? So if the reaction has a negative, then that means it's going to be sometimes spontaneous, and delta G will be negative at low temperature. So this is what we're looking for this first one, negative, and sort of the the logical progression, which is really the important part here. Don't just try to look at this table and say, okay, well, what's the answer? That'll get you through the topic. That's true. But what you really should be doing is sort of trying to understand, well, why are we saying this? What would be the effect of if I've got a negative change in entropy, if my entropy is decreasing as the reaction progresses, the hotter I heat that reaction up, that's going to make this term here, a larger and larger positive value, right? As this T gets bigger and bigger, then the fact that my delta S is negative means that this whole term is going to be positive, and as the temperature gets bigger and bigger and bigger, that's going to make this more and more unfavorable. And that progression, that's really what we should be focused on. Okay, let's do the rest of these here. This reaction is always spontaneous, but proceeds slower at temperatures. So the key here is the phrase always spontaneous. So always spontaneous is going to be negative delta H, positive delta S. The fact that it proceeds slower at temperatures, that's really just telling you about the kinetics of the reaction, and that can be related to lots of different things, but that's not related to the thermodynamics that we're talking about here. So the fact that the reaction proceeds slower or faster, that's what we call kinetics, and that's actually not related to the thermodynamics really at all. We can have spontaneous reactions that go really, really slowly, and we can have spontaneous reactions that go really, really fast. But what's important is the phrase always spontaneous. That's these conditions. Exothermic reaction, an increase in entropy is always going to be spontaneous, so that's what we're going to put in here. This is a negative. Hopefully it's clear there. It's a little sloppy. This reaction is spontaneous only above minus 28 degrees Celsius. So again, another way to write this reaction is spontaneous only at high temperatures. So again, going over to our cheat sheet here, that's going to be where I've got an endothermic reaction, but I've got an increase in entropy as the reaction proceeds. So if I've got an increase in entropy, if my entropy is positive, then the higher and higher I make my temperature, the more negative, right, the more negative this whole term is going to be, because I've got a positive times a positive. The bigger that gets, I'm subtracting that from my delta H, the more spontaneous the reaction is going to be. So even though I've got an endothermic reaction, that reaction can be spontaneous if my entropy is positive. So if my entropy is positive, then this term will sort of overwhelm the fact that I've got an endothermic reaction, and overall I can still get a negative delta G, and that reaction can be spontaneous. So this is how we do it. All right, let's do one more set for this topic. All right, so the first one, this reaction is always spontaneous but proceeds faster, so we don't care about this bottom part, we just care about the phrase always spontaneous. That means that we're gonna have a negative and a positive for our delta H and delta S. This reaction is never spontaneous, so here's a new one. If the reaction is never spontaneous, that means we've got this bottom case, we've got an endothermic reaction with a decrease in entropy. That's gonna lead to a reaction that's never spontaneous. This reaction is exothermic. So delta H is, they're just telling you, right? So that's nice. And then here, one of the options is unknown. So here, this is gonna be unknown. We can have exothermic reactions with positive entropy and exothermic reactions with a negative entropy change. So we don't know. So for the last one there, our delta S is unknown, but our delta H is very clearly, obviously, negative. Okay, hope that helps.